Welcome to Across the Globe. Today we will learn about services and dependency injection. Angular services are classes designed to handle specific tasks in an application. They facilitate data and functionality sharing across different parts of an Angular app. For instance, a service can manage API interactions, execute business logic, or handle various tasks imperative in an app. These services centralize and organize the codebase, aiding in maintainability and scalability. In Angular applications, services are frequently employed to handle interactions with APIs for data retrieval. A service class typically encapsulates the logic for making HTTP requests to external APIs. The provided snippet showcases a basic Angular service named Data Service. This service utilizes Angular's HTTP client module for performing HTTP operations. Within the data service class, the getData method is defined, which returns an observable. The getData method utilizes HTClient's get function to issue an HTTP GET request to the specified API endpoint, in this case, https://example.com/data. By defining and utilizing such services in Angular applications, developers can modularize code, promote reusability, and ensure a separation of concerns. This practice results in cleaner and more maintainable codebases, making it easier to handle API communication within Angular components. For instance, in an e-commerce application, a product service can be created to manage interactions with a product API, enabling components like product list component to fetch and display product data using methods provided by the service. In summary, services in Angular play a pivotal role in handling API requests and data management, facilitating efficient communication between front-end components and back-end APIs. Dependency injection is a design pattern where a class gets its dependencies from an external source rather than creating them internally. In Angular, this pattern is used to supply instances of services to components, directives, and other classes upon request. For example, in an Angular application, a service that fetches data from a server can be injected into a component that needs to display that data. This allows for flexible and efficient management of dependencies and promotes code reusability and testability. Dependencies in Angular are injected through the constructor of a class. In the provided Angular component example, the constructor function example component is used to inject a service called Data Service. This injection is done by specifying private data service as a parameter in the constructor. Once the data service is injected into the example component, it can be used within the class methods. In the method fetchData, the injected data service is utilized to fetch data by calling the getData method, which returns an observable. Subsequently, the subscribe method is used to listen for the data emitted by the observable and then log that data to the console. By utilizing dependency injection in Angular, components can easily access and utilize services such as data service without creating an instance of the service within the component itself. This leads to more modular, maintainable, and testable code in Angular applications. Just like how a pizza delivery service brings the pizza to your doorstep without you having to go pick it up, dependency injection in programming allows you to inject the required dependencies into the code without the need for the code to fetch them itself. Without a pizza delivery service, you would have to drive to the pizza place every time you wanted a pizza. Similarly, without dependency injection, the code would have to manually create and manage its dependencies, leading to a lot of repetitive and error-prone code. By using a pizza delivery service, you can focus on enjoying the pizza without worrying about the logistics of getting it. In the same way, by using dependency injection, you can focus on writing and testing the actual functionality of the code without getting bogged down in managing dependencies. Hey, code conquerors, ready to level up? With TechLearn ATG, showcase your skills with official course certificates. Just visit our site and start. Need that extra boost? Get tailored learning, 24/7 support and expert guidance, coding smarter, growing faster, and making learning fun. Go to our website across the globe, w.atg.world. The code illustrates the concept of services and dependency injection in Angular using a pizza delivery service analogy. In the analogy, we have a pizza delivery service class responsible for delivering pizzas with a method deliver pizza. The pizza service class is an Angular service with @injectable decorator. It has a dependency on pizza delivery service injected into its constructor using Angular's dependency injection system. When order pizza is called on pizza service, it logs ordering pizza, then calls the deliver pizza method from the injected pizza delivery service, and finally logs pizza enjoyed. Inside the app module, we register pizza delivery service and pizza service as providers using the Angular module decorator. This allows Angular to manage the injection of these services where needed. In the main.ts file, the app module is bootstrapped using Platform Browser Dynamic. To start the Angular application, by utilizing dependency injection in Angular, we can centralize and simplify the management of dependencies in our codebase. This approach mimics the convenience of enjoying a pizza without concerning ourselves with the intricacies of its delivery, enhancing code readability and maintainability. One real-world example of services and dependency injection can be seen in an e-commerce platform. For instance, imagine an e-commerce website that utilizes a payment service for processing payments. The payment service can be a centralized service injected into various components such as the shopping cart, checkout process, or order confirmation page. By utilizing dependency injection, the payment service can easily handle different payment methods, validations, and processing logic, allowing for seamless transactions across the platform. Another example can be found in a healthcare system that provides various medical services. Here, different services like appointment service, billing service, and patient record service can be injected into components across the system to handle scheduling appointments, managing billing information, and accessing patient records securely. By leveraging dependency injection, the healthcare system can efficiently manage dependencies between services, ensuring smooth operations and data flow throughout the platform. In conclusion, services and dependency injection play a crucial role in simplifying and organizing code dependencies in real-world applications, ensuring modularity, testability, and scalability. Across the globe, industries are leveraging these concepts to streamline application development and improve maintenance, ultimately enhancing user experiences and operational efficiency. Keep learning, stay curious, and I'll catch you in the next video.